Okay, so for our next presentation, we're going to be talking about IoT solutions in rapid transit, and I want to introduce Jim Allison, who is the Manager of Planning for the Capital Corridor Joint Powers Authority. Thanks, Jim.
Thank you. Hello all. Thank you for being here and sticking to it in the afternoon. I'm kind of related to the room next door, which is the kind of the smart cities corridor work, but I'm going to have the daunting job of trying to represent all of transit, and there's really so many different types of transit, and we'll just see. I have to kind of run through it and hang with it. So a little bit about us. We are operating in Northern California. We're an intercity passenger rail service. We are a managing entity. We contract with Amtrak for operations. We don't own our rolling stock that's owned by the state of California. And we operate on Union Pacific tracks, and then we contract operate with Amtrak. And so Amtrak is the one performing the service generally, and you can see our number of round trips between these different shaded areas. And we're essentially serving the Northern California megaregion. And that's my role, is to plan in and amongst all of that, anywhere from service, traditional rail stuff, but going into technology, and that's why I'm here today. So there's so many versions of transit out there. You have dial-a-ride, which is in that one corner over there with the van, and then you have rural bus routes, and you go all the way, even bike share is kind of considered a transit, and all of these different transit services are services right in the right-hand corner there. There's so many varieties of aspects about these transit services, so there's no universal solution and trend exactly in each type of transit, so we have to treat everything a little bit differently, but there are some common themes. So I'm going to try to draw those out and draw out the differences across the different types of transit as I move ahead. So we have differences in the vehicles, obviously. The ridership is very different. There's different fare collection mediums. The amenities on the transit vehicle for the public are different, and the trip duration is different. So that creates a whole host of different experiences for the transit operator and their customers. Where transit IoT starts to make sense is when demographics, funding, use cases, ridership, and organizational leadership, and the holistic understanding of all those things come together. So a lot of this is kind of developed from a silo system where we said, oh, we had an application, let's build this, and we need a cell card on it, so because the vehicle's moving around. So we'll do that, and we've done that a couple different times in transit. And now business cases are developing that, let's get rid of all these cell cards, let's get down to one cell card, and then have the data work across that from different applications. So there's a history and the evolution and funding that is very, very scarce, and the resources are very scarce in transit to take these steps. So there's a lot of risk aversion to taking risky moves, and so that kind of stifles some of the innovation, but it does force you to very unique solutions as you're moving ahead. So our space that we work in is both in the customer amenity, but also in operational efficiency. And this is one of the customer amenities that the reason why I'm here today is primarily because of the work we've done with Wi-Fi on trains. And this, if you've ridden on the East Coast on the Northeast Corridor, this is essentially the same system. It's a Wi-Fi, free Wi-Fi offered on the trains, and it's backhauled in our cases by cellular carriers. We aggregate the bandwidth across the 4 major carriers with SIMs on the train and the brain car, and then that's distributed over the train with hops between cars, or there's a digital train line now, which actually works much, much better. So the aggregated bandwidth that's provided is provided to all the passengers for free so that they can have a good trip experience. And that's what happens on our train, happens on the Acela trains, happens on the Northeast regional trains, and other trains around the world and so forth. It's a very similar system to what might be on a bus. It's just smaller on a bus. And, but the backhaul options are also that you could build your own network on the track side or use a satellite, which is increasingly rare because of the cost of the satellite backhaul. So in our situation, why does this work for us? Well, we operate in the Bay Area, and if you look at the home prices there in San Francisco, they're really high. So that's number one. Where do people live and where do people work? A lot of them want to work in those nice high-paying jobs in the city, but they cannot afford to live in that city. So one of the drivers is they need to live out there, away from that, but they want to be productive on their way, on their commute. And this is not the way right now to be productive. Along comes this rail service that we have, and you can be productive on the train. Even before we had Wi-Fi, people had their laptops on. But now with the internet on board, people are productive on the train. They can be social, and they can actually sleep, because a lot of people, including me, gets up quite early to make this journey. So Wi-Fi plays a huge role in that. In fact, it played such a huge role that we had questions about. We were early into the market, and Monica Paulina over here with Senzafili helped us analyze the business model for this. And we didn't know it at the time, but offering it for free became a really compelling business case, because if it's free, your transit service gets more attractive, and you might generate more ticket sales. And that is exactly our model. And we understood that if you increased trips on the train by at least about 1.5% more, you'd have a positive ROI. Well, we ended up with a research model that UC Davis looked at after surveys. We increased it 2.7. So we have essentially a paid-for system on our train to provide folks wireless internet. And our demographics also hit the mark in this in a very big way. We have high incomes, people who want to be productive, and they value their time on the train greatly. So where this exists around the country, around the world, Wi-Fi on a train or in a transit system isn't natural. So it's all about productivity, and when you look at these larger cities and the commute shed, this is when Wi-Fi on a vehicle, on a transit vehicle, makes big sense. And so intercity rail and commuter rail really, it fits into this quite well. But it's not always the case with all the transit systems. So on a city bus, it's not exactly an environment to pop open the laptop and do all the email. Light rail gets a little bit better. And a subway, again, awkward. You may be crowded. It's not a very productive time, but there are so many riders in the subway system that for the transit agency, it becomes compelling to work almost as a neutral host to provide Wi-Fi or provide access to the cell carriers that people have subscriptions for. So there's a vast range of appropriateness across the different transit types for Wi-Fi. But that's not the only story. Once you've put on a system like this, there are so many operational applications. We've covered just the Wi-Fi aspect of this, but there's all sorts of vehicle maintenance and telemetry information, status monitoring, on many different business cases that can be built and utilize this network and improve transit operations or maintenance, reduce costs. So the Wi-Fi, if you can get it for the passenger, is kind of like the Trojan horse. It's already working, it's been paid for, and then you have to build these other applications on top of that. And if you're a transit provider like a bus, maybe the Wi-Fi for the passengers is not compelling, but when paired with these other options, it becomes a cost-effective step in your business plan. So back in 2009, when we were working with Monica on this, we put out an RFQ for kind of the whole theory of making connected vehicles and organizing your entire operations around this. And then in the center circle, that was our way of saying it's IoT in the center. And everything was kind of coming to the center, from ticketing, from customer communications, internal communications, and then safety and security. So IoT in our world didn't exist, but that's essentially what we were pointing to back in 2009. We are still working and struggling to get to this IoT situation because of our resources and because of the staffing resources that are required to pull this off, and the business models. So the silos that we do have right now, every transit agency has fare collection issues. Some of them look at passenger counting. There's needs for video recording, be it for monitoring accidents, which could be done real time over a backhauled solution. And then the system performance sensor monitoring. So these all were silos before, but now under a common IP platform on the moving vehicle, they can report back and provide data. It's just that we haven't gotten here in many cases, or we haven't transitioned from those silos to a comprehensive system where data is shared and integrated. One of the things that's happened with transit has been the transformation of the smartphone. That has changed the way the customer relates to the service, and it's really the best application that Transit's had is to provide real-time information to that customer about the transit service. And that was always one of the big bugaboos about when's my bus coming? I don't even know. And so there's been all these iterations of trying to improve upon that, and now with the smartphone, it makes it ultimately very convenient. But not everybody has a smartphone, so there's also applications at stations. Data analytics is not our strong suit right now, but it needs to be, because we have very limited resources. We need to use those resources more effectively. But when we were paying for all these siloed bits of information, those connection fees start to mount up, and pretty soon it does make more sense to bring everything together. But implementing applications on top of that network, newer applications, can be very complicated. So the Wi-Fi system itself is providing the basis for using this next bit of technology that we're working on right now with Amtrak, and that's the onboard information system. So the Wi-Fi is the backhaul for this. This project is to provide video and audio automation announcements to the people on the transit vehicle, in this case the train, and it meets Americans with Disabilities Act compliance. It lets people know where things are coming, when to get ready for the station, and it provides some level of comfort about when you're going to get there. The real challenge with this project is to replace all the intelligence that a conductor has about saying what's going to happen. But also, that has to be all built into a system that's managed and kind of has a vocabulary of what could be said in an emergency or delay system. That is a big challenge, but it also, if done well, will overcome the inconsistency aspect of human performance in terms of one conductor doesn't like to make the announcements, but they should, those kind of things. The strange thing, though, is this project is about 4 to 5 times the cost of initially putting Wi-Fi on the train. So this is roughly what it looks like. This is an example in Germany. You'll see screens about when you're supposed to arrive, but this is your chance to sync this with the rest of your communications and make it brand your communications similarly to the rest of the transit. And it's also very, very high profile because they're a captive audience right there. So what's this going to do is it changes, this is the slide right here kind of showing what all has to happen behind the scenes to replace that conductor intelligence and the vehicle location. It's a very complicated interaction of messages across these different modules so that it can be pulled off successfully. Roughly, this is how it will work. The train comes along and it hits a geofence that says we're going to be arriving at such and such a time to the next station, and it gets you kind of ready for the next station, and by that station 2 minutes away it says it's time to get ready. You got to gather your bags, because we don't want to stop there a long time because that costs us time. And by the time you get to the station, it's welcoming the next people on the train and saying goodbye, thank you for riding. And then it goes off and does that repeatedly. Now, in between all of this, you can put ads, you can put other service messages to the customers. What this does for the transit agency, this is an application that will change the way the transit agency has to staff and respond to this opportunity. The whole section in the train operation control manager, the entire ops department, the dispatch department has to acknowledge how this is going to change business. And then on the advertising side, those other 4 modules are there. Those are new opportunities. It's new real estate, if you will, to possibly gain revenue, but also to communicate with the customers. So this is a transformative project built on the new system. So just a couple last slides here. We wanted to talk a little bit about data because of the Internet of Things issue about this. we should be doing much more with data. Of course, we're coming from the siloed world where the data comes this way, and then the next bit of data comes this way, and they don't talk to each other necessarily. But we knew these existed, so we asked our contract operator, which is Amtrak, to say, can you please push us this data, this bit of data? The common fields are train number and date, and by linking those two systems together, we have started to aggregate data. We don't have it, however, from all the business systems. But those graphs that you can see right down below, this is the start of this. This is how the train ridership builds up over the course of that route. And that's just one example. We get this data pushed to us on a dashboard every day. When we get into the office, we can look and see how the trains are doing. And then we can look at trends over time to decide what transit services we want to change. But we sell food on the trains too. We don't know how many Snickers bars are sold on Tuesdays on a particular train. Maybe we don't even ever want to know that, but it would be nice to know the answer to that if we wanted to. So that's the example of how far we might need to push this with data. And then finally, I talked a little bit in the earlier panel about security. Right now, our Wi-Fi network is not monitoring for hacked traffic. That's just not in the DNA of the vendor community that does that. So we're starting to look at a cybersecurity company that will monitor unusual behavior and be able to respond accordingly. It just wasn't built in at the time this was developed. I did talk a little bit about the physical security of these Amtrak ticketing kiosks. They can be accessed with a USB dongle very, very easily. And there is no action there because I asked Amtrak, what are we going to do about this? Because this is a vulnerability. They haven't gotten back to me yet on this, but you can buy that key anywhere. You can go in and have a good old time and see what you can do on their network. I don't know what you can do on their network, and don't try. But that's a vulnerability right there. The other vulnerability, not vulnerability really, it's just an issue of what do we do with this network that we have on these trains? How can we maybe monetize some of the customer traffic on that train? We have to get to a point of addressing privacy concerns about that. So we're just starting to learn about that. It's been years we could have done this, but again, we're resourced just to pull off enough to keep it running at this point in time. So everything's coming quite slowly. And then as transit fare mediums advance and move sort of to the smartphone that everybody has, there's going to be a move, instead of using your card, which I have the example of the Oyster card, which is used in London. Instead of using this, you might start to use your smartphone and manage an account. And then there's all the issues of what notifications do you want, how does that work across a region. In the Bay Area region, we have 27 different transit agencies. So it's really fun to organize all that and make everybody play nice together. So that's a big challenge. But it's an opportunity as well as to integrate better with that device that a lot of people have. So just to kind of reiterate what's going on in transit, Wi-Fi has certainly come along, and it's there for productivity and entertainment while in motion. It's not always appropriate for transit in all cases, but it's an important step. And then you can pair it with the other amenities to work on business operations. The onboard information systems that are built off of that are coming along, and we're hoping to implement that in the next couple of years. We're going to be doing our test train here coming up in the late summer. And then once we have IP networks, where we have to work on a better way to integrate this information, use it for our business decisions. And we're gradually trying to break down those silos or have those silos feed to a common central point. What would really help is transformation and information from this entire community to talk with transit about how to do things better, how to do data and security better, how to utilize your assets, how to know your customers better. So this is a great vertical interaction, and I wish there were more transit providers at this conference to learn about this, and vice versa. Please come to our transit conferences and start spreading the gospel, if you will. So, and the last thing, smartphones are a great tool to work between the cellular community, app developers, and the transit agency to improve mobility, and that is proving a very, very successful step. that's what I have. I don't know if I have any time left, but
No, unfortunately,
I'm
we're
all
running
done.
a little bit over,
Okay.
so I'd like to ask that
Thank
if
you.
you have questions, please feel free to grab them on the way out the door, and I'm going to have Stan jump up here